everyone, this is Mrs. Bokerman. Today this video is going to teach you about how to find the cross product and then how to use the cross product to actually find the equation of a plane. So let's get started. So first of all, you're going to have two different vectors. They can be u, v, whatever they are, and we're going to ask you to just simply cross them. So if I wanted to cross u and v together, I would first set up a 3x3 determinant. The top row would be I, j, and k. The middle row would be the first vector that you want, just the coefficients, whatever a1, b1, and c1 are. And then the third row would be the coefficients of the second vector. Okay, then in the previous video, we showed you how to expand a 3x3 determinant. And so what we're going to do is we're going to expand the row I, j, and k into smaller 2x2s. So if I'm looking at I, then it would expand and I would just have just B1, C1, and C2, because if I'm looking at I basically get rid of that row in that column. So I'm left with this tiny determinant. If I'm looking at the J row, then I would get rid of the top row and the middle column. And so I have A1, C1, A2, and C2. And then if I did the last one, if I had K, I would get rid of the top row and the last column, and I would have A1, B1, A2, and B2. And now you have smaller 2x2 determinants, which are super easy to evaluate behind. The biggest thing I want to point out is what often gets mistaken with this. This is a very algebraic procedure, but we often forget that the middle row is actually a minus j. It goes positive, negative, positive. If there happened to be one more, it would be negative, and they alternate. So this middle term is opposite j. Okay, now when you do the cross product, what you're doing is you're creating a vector that is perpendicular, but we call it normal when you're talking about planes. Okay, normal is the same word for perpendicular. You're creating a third vector that is actually normal or perpendicular to both vector u and vector v, whatever you cross them. So when you cross them, you're creating this third vector. So your answer is a vector. Okay, so let's see an example. Okay, so I just want you to give two vectors. I want you to cross them, u and v. So you see that the first thing you're going to do is set up your 3x3 determinant. The top row is always going to be ijk with 3 dimensions, and the middle row is the first vector that you're crossing, and the bottom row is the second, just their coefficients. Okay, so if I'm going to do that, I'm going to break it down. And I'm going to say I is going to be the 3, 5, 2, 3. So I get rid of this row and that column. Then it's going to be opposite j of the 2 and the 5 and the 1 and the 3. And lastly, the plus k with 2, 3, and 1, 2. Now from here, you're evaluating a 2x2 determinant, which is super easy. You do this diagonal, multiply it together, minus this diagonal, multiply it together. So 3 times 3, 9, minus 2 times 5, 10, 2 times 6, minus 1 times 5, 2 times 2, minus 3 times 1. And so I ended up with this. Okay, and again, you don't have to show this step. I just wanted to make sure you understood where these numbers are coming from. Okay, and so lastly, your answer is negative I minus j plus k. And that's it. You got a vector. So this vector right here, this minus I minus j plus k, is actually perpendicular, but we call it normal to these two vectors. Okay, let's try one more. Find a unit vector that is orthogonal or normal to these vectors. Okay, so we want perpendicular. So the first thing again is to set up your 3x3. It goes ijk. The first row is 2, 3, negative 1. And then I'm going to go ahead and break my determinants down. As you get faster and better at these, you might not even need to write out this step. But I just wanted to show you again where these numbers are coming from. So if I'm looking at the I, I'm going to use the 3, negative 4, and negative 1. And just be careful. These are very simple, but multiplying with negatives and subtractions, we sometimes make silly mistakes. Okay, and I'm going to set up the j determinant with the 2, negative 1, negative 2, and negative 3. I'm leaving out this column. And lastly, the k, 2, 2, and 3, negative 2, negative 4. Okay, and I will show you that when you get this, I skipped that step because I'm pretty sure you guys can multiply and subtract. And I ended up with negative 13, 8, and negative 2. Okay, now this would be great, except for going back to the very first part of it. It says it wants a unit vector. So if you want a unit vector, its magnitude has to be 1. So if you check the magnitude, a squared plus b squared plus c squared, it is not 1. So to make it a unit vector, I simply divide by its magnitude. So if it didn't say unit vector, I would have been done at -13, 8, and -2. But since it wants it a unit vector, I got to remember to divide each of those by its magnitude. And that's simply the cross product. So if we just ask you to cross two vectors, that's all you do. Now it's used for finding the equation of a plane, like a wall, like the ceiling, like the floor. Okay. So I'm going to first have you write down the steps, and then I'm going to try to explain it to you. Okay. So it's a 3-step process to find the equation. The first step that you're going to do is you're going to create two vectors using the points that you were given. Okay. So it takes 2 points to make a line. It takes 3 points to make a plane. Okay, so we're going to actually, you can't cross something unless you have vectors. So you need to first make two vectors. Then what you're going to do with those two vectors is you're actually going to cross them, which creates this third vector, as you see this one coming out, that stands for vector n, that's normal to the plane. And after you cross them, the last step is for you to dot that vector with any point in the plane to create the equation that will have the x, the y, and the z. So if you need to pause the video, go ahead and write that down. If not, I'm going to kind of explain what those steps are all about. Okay, so the problem is going to say, write the equation of this plane, and notice you have 3 points. These are not vectors because these are parentheses. So the first thing I'm going to do is, like, I have 3 points, and they're going to make up some plane in space. So the first step I'm going to do is I'm going to actually make some vectors. Okay, I'm going to make 2 vectors. Now, you can really do them in any way that you want. I always like to make a vector going from the first point to the second, as well as the first point to the third. But you will get the same answer in the end if you do like I to H or K to I. It does not matter. But as you can see, I'm basically making 2 vectors. So these are position vectors, meaning I actually need to subtract. So the reason I got these numbers here is because I did 3 minus 1, -1 minus a -1, 1 minus 2. That's how I got HI to be 2, 0, and -1. And then similarly with HK, I did 2 minus 1, 1 minus -1, 3 minus 2. Because remember, when you're doing a position vector, you subtract the second minus the first. So that's kind of what's going on. Okay, the next step is to actually cross them. Okay, so I'll kind of show you. I'm going to cross them. Okay, so I'm going to do the cross product, break it down, my rows, my i's, j's, and k's, and I end up with this vector here, 2, -3, 4. So what that means is I created 2 vectors, and I made this 2, -3, 4 is the normal vector that is perpendicular or 90 degrees to the plane that had those other 2 vectors. Okay, then what I'm going to do is I'm going to take this and I'm going to make almost like a second position vector from any of these points. I always like to use the first point, but really it doesn't matter which one you use. So I'm picking point H, and I'm going to create a position vector out to some arbitrary point x, y, z, because I should be able to use any point in the plane, because when you have an equational line, you can use any point on that line. So I'm using any point in the plane. I always like to just pick the first one. So what that means is I'm going to take the dot product between our normal vector that we just found, and I'm going to pick the green vector. What you see is a position vector from H out to x, y, z. And so how do you find that vector? You just subtract. So if H is 1, -1, 2, what that looks like is I'm going to do the dot product between my normal vector and x minus 1, y minus a -1, which is +1, and z minus 2. That's where this part comes from. And because when I dot them together, they are perpendicular, that means that they're actually equal to 0, which is why you want to use the normal vector. So then what I'm going to do is now I'm just going to do algebra. So now this is going back to the beginning. The dot product means that I'm going to multiply whatever's in the I spot with the I spot, whatever in the J spot with the J spot, and the Z spot with the Z spot. So I'm going to multiply. Okay. And you could technically leave it like that. I'm going to go a little bit farther and just show you what kind of it looks like. So I'm going to distribute. Okay. And then I'm going to have 2, -3, -4. And I kind of put all the numbers together so that I could just add them together. Or most likely when you're given the equation on plane, you're given the x, y, and z and the number on the other side. It really doesn't matter when you stop. I just wanted to kind of show you that this answer at the end, that is the equation of that plane that contains those 3 points. Okay, so it's kind of a long process, but that's mainly where the cross product is used for. I'll give you one more example, and feel free to pause it along the way for you to try it on your own. Okay, so what I'm going to do is find the equation of the plane containing the points A, B, and C. It really doesn't matter what you call them. So again, these are points. I need to cross vectors. So what I'm going to do is I'm going to make a vector go from A to B. So I'm going to do 8 minus 3, 2 minus a -1, 4 minus 2, and I'm going to make a vector go from A to C. So -1 minus 3, -2 minus -1, -3 minus 2. And then I'm going to set them up in my 3 by 3, and I'm going to cross them. So if you want to pause, you can actually try it on your own and see if you get the right answer. But then you actually get -13, 17, and 7. Okay, now what I'm going to do is this vector that I created is normal to the plane. So I'm going to use point A, just because I always like to use the first one, or sometimes I like to use the one if it has a lot of zeros in it. Okay, I'm going to use point A, and I'm going to dot this point with another point in the plane, which is x, y, and z. Okay, so I'm going to take my normal vector that I got from the cross product, and I'm going to take my position vector from point A to x, y, and z, and I'm going to dot them together. And because they're normal, because they're orthogonal, because they're perpendicular, when I dot them together, they're 0. Then I'm just going to do algebra. I times i's, j's times j's, k's times k's, and I get this. Okay, I went ahead and combined all the numbers already together. So it doesn't matter. You can move the number to the other side or leave it there. But the biggest thing I wanted to point out is what's interesting is these coefficients are actually the coefficients from the normal vector. Okay, so that is the cross product, and that is one example of where the cross product is used. It is used to find the equations of planes, and that's why you need 3 points so that it makes a plane. So the next thing I want you to do is go ahead and practice and then check out the homework. Thanks for watching.